Today we're going to look at arithmetic sequences. An arithmetic sequence is a number pattern where each consecutive value has what we call a common difference. And from now on we use the letter D to denote the common difference. So I have an example of a number pattern here, 2, 5, 8, 11. And what we do here is that we take the number on the right minus its number on its left, and that turns out to be 3. So 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3. So as long as we keep getting the same number over and over, we would say in this particular case D is equal to 3. That's the common difference. Now real quick, we could have had a number pattern that went something like this. Maybe it went 11 and then 8 and then 5 and then 2, and maybe it kept going in that direction. Now this time, if we take the difference, 8 minus 11 is actually a negative 3. 5 minus 8, negative 3. 2 minus 5, negative 3. So in this case, D would equal a negative 3. So you got to be careful and make sure that you get the right difference, whether it's a positive or whether it's a negative. So to continue on, we're going to look at this example here, and we could actually make a table of values is what we're going to do next. So I'm going to make a table of values and do this kind of thing. And the on the x's, normally it'd be the x and y's, but we're going to call this the term number on the top, term number. And that's going to be n. It'll be the letter n. And below that, we're going to have the term value. The term value. And that's going to be denoted a sub n. And I'm going to start with 0 here. And you say, well, why are you doing that? You're going to see in a minute. So the first term, I'll change the colors here. No, maybe I'll leave it white. The first term is a 2. The first term is a 2, and that was, I'll go ahead and make that green, that's fine. And the second term is a 5. The second term is a 5. So make that green. Second term is a 5. And let's keep going here. The third term. And the third term is an 8. And that was supposed to be blue. There it is. And the fourth term that we have so far is 11. That's an 11. And that's the fourth term. So that's how we can kind of think of it. Now what we want to do here is we want to come up with a rule. Okay? We want to come up with a rule. And I'll put that over here. So we come up with a rule. All right, and we already know the common difference was 3. So what that does, it helps me with the rule. I already know that the rule is going to be 3n because the common difference right here was 3. Now, the reason why I have the 0 term right here, if I was to go backwards, I kind of look at the pattern. I add 3 to go forwards, but if I actually subtracted 3, I would end up with a negative 1 here. And that helps me with my rule because my rule is now going to be 3n minus 1. That's the rule to get any term. So for instance, let's say I wanted to know the 20th term. Now I could just keep adding 3 over and over again, but actually all I have to do is I look at my rule here and I take 3 times 20, because that's a 20. 3 times 20 is 60. 60 minus 1 is 59. So what the rule does, it allows me to get any term number value I want. Okay, so if I want the value of the 20th term, I just use the rule. Now let's look at a quick graph of that. And let's see. Now the graph only depicts the first 4 terms. So go ahead and paste that in there. Maybe I'll make that a little bit larger. And this is basically a linear function, okay? Now, it's linear, however, it does not, the dots do not connect. You leave them separate. You can see from the, let me move this down a little bit. See if I can move this whole thing. Okay, move that down. The dots do not connect. This is not a continuous function, and because these are individual points. Now, the one point I didn't graph is 0, -1. It's not really part of our sequence, but it helped us to get the rule. So, and you can see that there's a slope here. If you go down 3, left 1, if I go down 3, left 1, that would also fit right here, and that would get my 0 term right there. Now, there's another way to that you'll see the information listed sometimes. So I'm going to go ahead and list the values that I started with. So that was a 2, a 5, an 8, and an 11. And sometimes you'll see it listed like this. Underneath, they may say, okay, this was A sub 1, this is A sub 2, A sub 3, A sub 4. Okay, that just means basically the first term is a 2, second term's a 5, the third term's an 8, the fourth term's an 11. But you can always rewrite that. You can always rewrite that into a table form such as we have here. So another thing you're going to have to be able to do is this next example here. So let's say you're given two values. Let's say you're given, this is going to be a different problem with a different rule. So all they tell you is that A sub 5 is equal to 14. A sub 5 is equal to 14. And A sub 22, A sub 22 is equal to 48. That's all you know. So at that point, they're going to say, okay, come up with a rule. What's happening here? Well, obviously, if they're telling you it's an arithmetic sequence, so you're going to be adding some number to 14 to get all the way to 48. So what we want to do here is we want to set it up like this. We're just going to say, okay, 48 is equal to 14. It's equal to 14 plus, it's equal to 14 plus some difference. I don't know what it is, the difference. And then the thing is that I've got the 22nd term versus the 5th term. So I just take 22 minus 5. And that's because how many terms away they are from each other. This is the 22nd term, this is the 5th term. Now it turns out that 22 minus 5 is 17, but I'll go ahead and continue the problem. So right now I can solve for the difference. So I know that 48 is equal to 14 plus 17d. 17 times d. Okay, so I'll go ahead and subtract the 14. Let's see, so I'll subtract 14 here. And that's going to give me, don't like my 4 there, that's okay. That's going to give me 34 is equal to, go and just make that white, 34 is equal to 17d. And if I divide by 17, it turns out that the difference, which is d is equal to 2. Well, I still haven't figured out the rule yet, but I'm almost there. So all I have to do now is I'll go ahead and use the 14 up here, because I like to work with the smaller numbers. So I'm going to say this. I'm going to say that 14 is equal to A sub 0, because that's going to make life easier for me if I can find A sub 0. I didn't really like the way I wrote that. A sub 0 plus a sub 0 plus 2 times 5. And you say, where did the 5 come from? The 5 came from right here because this is the 5th term, and I'm trying to find the 0th term. So all I have to do is really just subtract 10 from both sides. Go ahead and do that, because 2 times 5 is 10. Just save a step here. Minus 10, and so a sub 0 is going to be 4, equals 4. Now remember, to find my rule, I need the difference. So my rule is going to be a sub n is equal to the difference, which is 2. So it's going to be 2n. And then the 4 comes in handy. It's going to be plus 4. Plus 4. I was going to make that white. Doesn't really matter. Let's see. 2n and then plus 4. I'll make that green. So there's my rule. There it is. That's my rule that would generate these two values up here. Okay. Let's test it. Let's see. What's 2 times 22? That's 44 plus 4 is 48. So that seems to work out. So there you have it. That is some of the key features of arithmetic sequences.